Okay, well now we'll move on to this, something a bit different, which is this library database. So I'll just show you what this looks like. So this is meant to be it's very simplified, but it's a list of books and a list of library members and a list of what books they've borrowed. So you can see how this is, so there's a certain syntax to this, to these facts. So the author is written in this way, author bracket, and then the last name, comma, the first name. So this is, sometimes we refer to this as just syntactic glue. So the fact that we use the word author with round brackets is something that we've just decided, that it's going to be written in this way, and when we do a query it tries to match the pattern. And then we decide that books are going to be written in this way, so we're going to have the book number first, and then the title of the book. And you notice how the title is a string, and the string is written with single quotation marks, and then it says the author in this format. So, you know, the book one is Prolog Programming for Artificial Intelligence, written by Ivan Bratko, and then we have Tehanu by Ursula Le Guin, and so on. So there's a list of what books are in the library. And then the members, and again this syntax is just something that we decide, that it's, if we decided to list them in a different order, then they would search for a query in different order. But that's just the format. So member number one is a person called Joe Bloggs, and this is their address. And then we have who's borrowed what. This is saying that book number 4 was borrowed by library member number 1 on this date, and that's the due date, and then the date is written in this format. So we say the year and then the month and then the day. So we've just said all of these facts in this format, and then these are the rules. So, well, we can query this just by typing in, trying to get at these facts directly. Yeah, so this is the problem, because you have to match the format exactly. So you have to know that it's in this format. So let's say, what is book number 1, for example? TA, and it says, okay, the title is this and the author is this. I can say, well, I'm looking for a book and I know it's written by someone whose first name is Ivan, but I don't know anything else. So I just provide what information I have and ask it to search for everything else, and it comes back and says, oh yes, Ivan Bratko wrote Prolog Programming for Artificial Intelligence. So I can do search directly on these facts by just putting in the information I have and putting variables in the other slots. And then we can look at who borrowed which book. Yeah, so this is, in principle, this is exactly the same as teachers and studies, but it's just a little bit more complicated. So I won't go through these examples on the command line, but you just see the way the rule is written. So if we say that a person with a certain name borrowed a certain book, it says, okay, I need to find a member of the library who has that last name, right? So they have to have a certain member number and they have to have a name. Now, these underscore, I should mention about these underscores. So the underscore means we don't care what's in that field. We don't care what their first name is. We only care that their last name matches this, and we don't care where they live. So that underscore means there has to be something in there, but we don't care what it is. But then there has to be a book with a certain catalog number, and there has to be a record of a loan that matches the member number and the catalog number. And we want the title of the book, we don't want the author, and we don't want the date. We just want to extract this information. So it's all about putting in the information you have, putting variables in the place where you want the information out, and putting underscores in everything else. So if this rule is there, I don't know if it's, let's just say borrowed XYZ, and it comes back with all the possibilities. Okay, so someone called Blogs borrowed the Turing option, which is catalog number 4, and also borrowed the left hand of darkness, and so on. So it comes back with a list of everything that's been borrowed by everyone, but it only reports the information that we asked for. It suppresses everything else. All right, so let's move on to arithmetic. So how do we do arithmetic in Prolog? So in this case here, we're actually wanting to tell whether a book is overdue. So we've got 2 dates, and we want to tell whether one date is later than the other date. Yeah, so let's have a look at these rules. So you've got one date that's specified as a year, a month, and a day, and you've got another date in the same format, and you want to tell whether this date is later than that date. How do you do it? So is the 1st of the 4th of 2010 later than the 7th of the 4th of 2010?
So compare year.
No. Yeah.
And then if they are the same, that you compare months, and
Right.
if they are the same, you compare days.
That's right. Yes. Very good. So if you first you compare the year. So if the year is later, if one year is later than the other, then you don't have. It doesn't matter what the month and the day are, right? So this is actually, we've written these in the reverse order. So look at the bottom one first. So if we've got some date which is year 1 and any month and any day, and then this is year 2, and if year 1 is bigger than year 2, that means this is later than that. So we've actually, maybe it's logical to think of it the other way around, but we put that last, yeah. So, and then what happens if they're the same?
You need to have a second
Right.
condition.
Yeah. So it's very good. So the logic is correct, but you're, I mean, I'm not meaning to criticize, but you're sort of thinking in terms of an imperative language. You're thinking, okay, first you compare the year, and then you compare the month, and then you compare the date. Yeah, which is not natural, but in Prolog we sort of think in a slightly different way. So instead of saying if this, else this, else this, we split it up as 3 separate rules. That rule covers the case where the 2 years are different. And then if the 2 years are the same, we compare the month, and if this month's greater than that month and it's later, and then if the year and the month are both the same, then we compare the day. So, right, so I told you that the comma is an and in Prolog. So you might ask, well, if comma is and, then what is or? Now there is actually an or in Prolog, which is a semicolon, but it's normally considered bad style to use it. So this is normally the way we achieve or, is having separate rules. So this, having 3 separate rules for the same predicate effectively achieves having this or this or this. I might just make a point about style while we're here. So you could rewrite this rule as follows. You could say, okay, this is year 1, and that's year 2. And then I say, okay, if year 1 is equal to year 2, and month is greater than month 2. So I could have 2 different variables and then say that they have to be equal. But it's actually better style. If you want things to be equal, it's better style to just give them the same name. If I say y and y, that rule can only be applied if those two y's are the same. Right? So this is just a kind of point of style. I'll say a little bit more about that equals in a minute, but the equals just tells whether two things are the same. Okay, so this is better style than that. So when it does the search, first it tries to test the top rule, then the next one, then the next one. And if you think about it hard, you actually can realize that these are mutually exclusive. Like, if one of these matches, the other ones will have to fail. Like, it's not obvious, but that is actually true. Okay. Let's see. Later, date. True, right? And if you want, you can trace it. Right, it normally applies the rules in the order that they're written. So first test of 2017 is greater than 217, that fails. Then it tests if 5 is greater than 5, that's the second rule, and then it moves on to the third rule, right? Okay. And then we can test whether something's overdue. So this due date, you give it a year, a month, and a day, and it tries to, usually you borrow a book for 1 month. So, okay, this is important actually. Okay, so I want to calculate the due date. So I tell you the date that a book was borrowed, and then I wanted to tell me the date that it's due on, right? So you're given the year, a month, and a day, and then the due date is going to be the same year and the same day, but the month is going to be 1 month later, right? So if it's borrowed on the 5th of February, the due date will be the 5th of March. That's the functionality we want. Now there's a little complication here, of course. If it's December, then the month will be January of the following year. So this handles that case. Now, but if we look at this, we have to have a way of doing arithmetic. Now in Prolog, now again, if you think imperatively, you would expect to see month equals month plus 1. Right? If you were writing this as a C or a Python program, you'd get the month and then you'd say month equals month plus 1. You know, or x equals x plus 1. Now, in Prolog, you're not allowed to say month equals month plus 1 because it's a logical language, and how can it be the case that month equals month plus 1? There's no value of month for which that is true. So you need actually two different variables. So we start out with month 1, and then we have month 2, and we say month 2 is month 1 plus 1. So this is actually calculates this value. So if month 1 was equal to 5, it calculates this and figures out that it's 6, and that becomes month 2. Okay. So when we run this, okay, so date, right, so let's say we borrow a book today. What date will that book be due? It says the 4th, and then if we trace it, okay, so first checks to make sure it's not December, and then this is the point where it does the actual math. It says, okay, 3 plus 1, the is actually evaluating this and making it equal to 4. So 4 is 3 plus 1, and then it comes back with the answer. Now, of course, this is a bit naive. What would happen if we borrowed a book on the 31st of January? It comes back and says it'll be due on the 31st of February. What is that? So it's pretty pretty dumb, but you get the idea, okay? Now, so let me say a little bit more about how arithmetic is done. So we don't have any logical error here. These are two separate things. Month 1 is 3, month 2 is 4. So that we don't have x equal x plus 1. Now, this is kind of how arithmetic is done in Prolog, but it's helpful to just play around and try to figure it out. So if I say 5 equals 5, that's true. If I say 3 plus 2 equals 3 plus 2, that's true. If I say 3 plus 2 equals 5, that's false. Now, this equals, so this 3 plus 2 is actually a compound object. It's actually an expression. It hasn't yet been evaluated. So this equals, for two expressions to be equal, they have to really be identical for this particular equals. Now, if I want to extract the value, I say 5 is 3 plus 2, and it says true. So this is, what this is actually does is it takes the right-hand side, evaluates it, and checks that it's equal to 3 plus 2. So if I say x is 3 plus 2, it says x is 5. Now, this is a one-way street. If I say 3 plus 2 is 5, that's no good, because the value has to be on the left-hand side and the expression on the right. So the is, I have to put information on the right and it calculates something on the left. So this way around doesn't work. Okay, so this is the thing. So we've got equals and we've got is. There's two separate things. Now we can also do inequalities. 4 is greater than 2, is that true? Yes. 2 is greater than 4. 3 is greater than or equal to 3. Now here's a tricky one. 3 is less than or equal to 4. It says an error. Now the reason for this is this symbol here has a different meaning in Prolog. It's some kind of funny arrow. So instead of, if we want less than or equal to, we have to write it this way around. And then it's okay. So there's some funny little quirks here. Okay, so where are we? If I want to test whether two expressions are the same, so is 3 plus 2 the same as 4 plus 1? Well, if I do is or equals, this is going to fail. So the symbol that I need is the following. Equals colon equals. That means I want you to evaluate both sides and check that they're equal. So there's a lot of these little subtleties. Well, you kind of get used to this. There aren't too many, but there's these slight subtleties here about things being equal and not equal. Are there any questions about this at this stage? Yeah. Yes?
Why is the semicolon rule considered bad practice, and will we be penalized for using it?
Usually you will be, unless we explicitly say otherwise, you shouldn't use it. Yeah, it's almost always considered bad. Well, it makes the code hard to read. It's usually better to split it up into multiple rules, and if you've got a semicolon like embedded in the middle of a rule, then it's better to pull it out as a separate clause and separate it out that way. Yeah.
Can you run like a script? Can you run Prolog scripts or not?
You can run Prolog scripts. At the moment, we're just loading one file, but we can actually we can load multiple files. Let's say I edit this. So I've loaded library.pl, right? Now, let's suppose I go away and I've edited the file. It's different now. I've added a rule or something. Well, I could quit out of Prolog and launch it again, But the other thing I can do is say consult. I think I got this right. If I say consult library, that means I want you to go back to that library.pl file and recompile it. So if I've removed rules, I want you to forget about them, and if I've added new rules, I want you to add them in. So this way, you could be editing in one window and typing in the other, and you don't have to keep quitting out of Prolog and relaunching it. So that's like if a file is changed, and then it's also possible to load multiple files. So if I do this, that says load, that's another way of getting it to load library.pl, but this way I can load multiple files. Like if I need 3 different files, I can put these one after the other, and it'll load all the rules in all of them. And then you're asking about a script. The way we usually do it is we just say Prolog out. We have a list of instructions, and we just say Prolog caret and then the name of the file. Yeah, so there's ways of doing this. You can run the whole thing in batch mode, essentially. Yeah. Let's see. So a little bit more. So I just pick up on this asymmetry of is. So 5 is 3 plus 2. Right, so if I say x is 3 plus 2, that's okay. But if I say 5 is 3 plus x, it refuses. So this does have a unique answer, but it refuses to compute this. So is always a one-way street. When Prolog sees is, the right-hand side must be fully, you can't have any free variables on the right-hand side. The information always goes this way and not the other way. If I can say, if I say x equals 2 and y is 3 plus x, that's okay, I think, because by the time it gets to here, it knows what x is. So it's okay to have a variable here, but by the time it gets to that rule, it must know what the variable is. So this is why, if we remember this thing about the due date, I can't ask it the other way around. So date 2017 42. So if a book is borrowed here, then that's the due date. But if I try to ask it the other way around, well, if the book is due, let's say the book is due on the 5th of May, when was it borrowed? It refuses to answer that question. And if you trace it, the reason is because when it gets to the is, it's like snakes and ladders. The is can only go one way. So by the time when it gets to the is, well, we can't really see it in the trace, but the is there in the rule, and then when it gets to the is, it's not sufficiently instantiated. Yeah. So in some situations we can ask queries both ways, but when we use is, unfortunately, like it breaks the symmetry. We can only go in one direction. Okay. We're nearly out of time. I mean, this is kind of extension, but I might just mention this because it may help you understand a bit better. Like, these things can actually be written behind the scenes. Almost everything in Prolog is like bracketed operators. So when I write 3 plus 2, that's actually the same as plus bracket 3 comma 2. But this 3 plus 2 is the preferred way of printing it. So if I say what's plus 3 bracket 2 equals x, it'll actually come back and say x is 3 plus 2. And if I say plus of 3 comma 4 and 2, this is at 3 times 4 plus 2, and it's actually smart enough to understand operator precedence. this is actually, this here is actually what's really going on behind the scenes, and this is just the way it's printed out and scanned. But it knows that if it's 3 plus 4 times 2, that this has to be bracketed in order to get the right answer. But here, it doesn't need the brackets. So, and you can actually, there are ways to change the operator precedence. There's little rules you can put in that says that one operator should have precedence over another. And if you write something as in this way, you can specify which side gets evaluated first. So there's these weird sort of technicalities that you can play with, but most of the time we don't need this. We just go with these defaults. Yeah. Okay, that's a lot for today. Okay, is there any final questions? Okay, so labs tomorrow, labs Monday, labs Tuesday, labs Thursday. Do the online exercises, and I'll see you back again next Thursday.